Okay, hi everybody. So this is page 74 now, and we're looking to generalize the ideas that we've encountered so far a little bit further. Now, this is probably the most technical bit, so it does get easier after this, and we'll be breaking down this formula, investigating where it comes from. Now, hopefully you've already watched the video on page 73. What we found out was if we want to find a point 3/4 along the line AB, we said we could go along A, and then we could go 3/4 of along the line AB, which is equivalent to B minus A. We broke up the algebra and we found out that this fraction, A plus 3B over 4, that can get us there. And that's kind of convenient, you know, it's in some ways it's faster. The other thing that's quite good about this is we can generalize it to any fraction, any ratio. So it wouldn't have to necessarily be 3/4 of the way along. It could be a fifth or 4/5 or 4/7 or whatever you want, whatever fraction, whatever ratio, we can do it. And this is the formula over here. Put a little green line on it already. I did actually record this once and then I forgot the names of the Greek letters, so I had to do it again. So this is what we've got here. We're looking to divide the line AB in the ratio lambda to mu, right? So don't be afraid of these. These are just Greek letters. They're placeholders for numbers. And here's the formula here. It's mu times A plus lambda times B all over lambda plus mu. Probably seems a little bit weird, but let's keep in mind what we did in the previous page. Last time, we split it up in the ratio 3:1. In other words, we found the point that was 3/4 of the way along the line. So in this case, lambda would be 3, mu would be 1. You'd substitute those into this equation. So instead of mu A, it would be 1A. Instead of lambda B, it would be 3B. And then instead of lambda plus mu, it would be 3 plus 1. And then, of course, that simplifies to 4. All right, so it's not too bad of a formula. I'll just sort of show you where the formula comes from next. Done it wrong. Okay, knew I'd do it wrong at least once, but that's fine. So we are looking to generalize this formula. We're looking to see where it comes from, basically. So what's going on here is we're starting at the origin. We're going to the point A. And we're going a certain ratio along the line AB. We want to split it up into the ratio lambda to mu. As a fraction, remember what we did with fractions, we said that the left number is what's on top and the bottom is the two components added together. So this is the fraction that we'd want to find our way along AB. To work it out, we're going to go from the origin to A, and then we're going to go that fraction along the line AB. Going from the origin to A can be written as little letter A. That in yellow. There we go. Lovely. Keep this weird looking fraction here. The vector AB can be written as B minus A in terms of little vectors. Now what we're going to do is we are going to expand this thing here. So there's a bit with A and a bit with B. So we're going to have this for B. This for A. And this part matches because in our formula there is a lambda by the B, not a lambda by the A though, so we're going to have to see where that's going to disappear off to. There's also this part over here, which I don't really want. So what I'm going to do is I'm going to change this so that I can write it as one fraction. Our eventual answer is one fraction here. So I'm going to multiply this single A by lambda plus mu on the top, lambda plus mu on the bottom. Of course, when you times anything, if you times the top and bottom by the same thing, you're not actually doing anything, you're just finding a way to rewrite it. This is kind of what we've done over here. We've just found a way to rewrite this expression so that all of the fractions have the same thing on the bottom and we can combine it all together. Okay, so we can now write it as a single fraction. We'll times at the top. So we've got lambda a plus mu a over lambda plus mu. Oh, I should have wrote it as a single fraction. I said I was going to do that. Never mind. Let's write it again. Okay, so I can write it as a single fraction. There we go. And the lambda a terms cancel out. And there's my formula. Cool. So in the sort of specification for the A-level syllabus, they've said that you are supposed to know where this formula comes from. I can't see a way of them testing it unless they specifically asked, just prove this. They haven't done that yet, but do keep in mind that it is there.